Hi, eighth graders. In this video, we're actually going to work on dilating figures on the coordinate plane. Kind of like we did with rigid motion transformations. We started off just in general what it looks like. Now we're going to get very specific on how to do this in the coordinate plane. So our learning goals, we're going to dilate figures on a coordinate plane. We're going to understand the dilation of a figure on the coordinate plane as scaling up or scaling down, and actually how that affects the coordinates of a figure. And for this video, we're going to consider dilations centered at the origin. So I'm going to jump. We're going to jump around. We're going to skip a few things here. We're going to go to activity 2.2, which starts on page 129 of your book. We're not really going to go in the order that they have this done. We're actually going to start with problem number 2, but we'll kind of read what's going on in this activity, and then we'll go to number 2. So it says road signs maintain a constant scale regardless of whether they are on the road or in the driver's manual. This sign indicates that the road is bending to the left. Okay, so constant scale meaning they could be any size, but they're going to look the same. Okay, so it tells us to dilate the figure that's on the coordinate plane. So A, B, C, D, this square, using the origin as the center of dilation and a scale factor of 3 to form a new figure. So that's our task. That's what we're going to be doing. We're not going to do that right now. We're going to actually jump down to number 2. It says list the ordered pairs for the original figure and for the new figure. So here's the original ones. Go ahead and copy those. And then we're going to work together on what to do to get the new figure and the ordered pairs for the new figure. It told us that we're using a scale factor of 3. So scale factor, another way to think of this is like a growth factor, okay? It's bigger than 1, and we've already learned that if a scale factor is bigger than 1, that it's going to enlarge it. So this is kind of like growing by a factor of 3. Well, when we hear the word factor, we think multiplication, right? Factors of this are two numbers that are multiplied to give us this number. So a scale factor, or like I said, an enlargement growth factor of 3 means that whatever these coordinates are, we're going to multiply them by 3. So we're going to take all of these things and we're just going to multiply by the scale factor, which was 3. And that's going to give us the coordinates of the new dilated image. So A prime. We're going to get A prime by taking the x coordinate and the y coordinate and multiplying them by 3. So 2 times 3 gives us 6 for the x coordinate. 3 times 3 gives us 9 for the y coordinate. B prime, we're going to do the same thing. Multiply the x coordinate, multiply the y coordinate. So 4 times 3 is 12. 3 times 3 is 9. Why don't you pause the video, try C prime and D prime on your own, and then we'll come back and check them. So to get C prime, you should have taken C and multiplied the x coordinate and the y coordinate by 3, and you should have got 12, 3. For D prime, same thing, multiply the x coordinate and the y coordinate by the scale factor, and you should get 6, 3. So here are the coordinates. Now let's actually plot these things on this graph. So do this with me. We're going to plot A prime at 6, 9. So 6, 9 is right here. This is A prime. B prime was 12, 9. So over here's 12. 9 is right there. So there's B prime. C prime was at 12, 3. And then D prime was at 6, 3. Go ahead and connect the sides here. I'm just going to do the square. I'm not going to do the logo that's in the middle of it. And here is the image of that road sign after a dilation of 3. Here's the new old coordinates, the original ones of the pre-image. Here's the coordinates of the image. We got it by just multiplying by 3. Now let's compare and contrast the corresponding angles and the corresponding side lengths and just write down what we notice. Okay, so let's look at the angles. So angle A here, it's kind of easier than our previous videos. This is a 90-degree angle. It's a right angle. This also appears to be a right angle. Same with B, C, and D. So it looks as if the angle measures stayed the same. So I'm going to write that down before I even think about the side lengths. The measures of corresponding angles are equivalent or stay the same. Now let's look at the side lengths. Let's actually put in side lengths here and see what we notice. So I'm going to go to the original one. So from A to B, this is 2 units. B to C, it's also 2 units. It's a square, so it's going to be 2 units on each side, right? Let's count how many units we have here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It's going to be 6 units on each side. So what do we notice about the side lengths? They were 2, now they're 6. Looks like they also grew by a scale factor of 3. So not just the coordinates, but that also affected the side lengths by the same scale factor. So for number 3, let's add on to that. The side lengths also grew by a scale factor of 3. So there's an example of an enlargement. Scale factor bigger than 1. We take the coordinates of the pre-image, the original, and we multiply the x and the y coordinate to get the coordinates of the image, of the enlargement. Let's turn the page to page 130 now and look at a different sign. So this is WXYZ. We're going to dilate this figure again using the origin as the center of dilation, but now the scale factor is 1/2. What do you think is going to happen with a scale factor of 1/2? Just answer that in your head. What do you think is going to happen? It's less than 1. Hopefully you have an idea. Let's see what happens. So we're going to do the same thing. We're going to jump to number 5. I've already given you the ordered pairs there of the original. So copy these, please. Pause. Copy those. And again, if we're using a scale factor of 1/2, that means that the coordinates are going to be half of the original ones. So in order to get the coordinates of the image, we're going to take these and we're going to multiply again by the scale factor, which is 1/2. So we're going to multiply by 1/2 and we're going to get the coordinates of the image. So we'll start with W prime. The x coordinate was 8. 8 times 1/2 is 4. Y coordinate 10 times 1/2 is 5. So W prime is going to be at 4, 5. X prime, do the same thing. X coordinates 10 times 1/2 is 5. Y coordinates 8 times 1/2 is 4. Why don't you pause the video and try Y prime and Z prime on your own, and then unpause and check your answers. Y prime, you multiply the 8 and the 6 by 1/2, and you should get 4, 3. And for Z prime, multiply the 6 and the 8 by 1/2, and you should get 3, 4. Here are the coordinates of the new image after this dilation using a scale factor of 1/2. Let's plot it and just see what happens. So W is going to be at 4, 5. So right here is W prime. X prime was at 5, 4. So here's X prime. Y prime, 4, 3. And then z prime was at 3, 4. And we'll put in the sides here. We'll just connect them so we can get a better idea of what's going on. And there's that shape. I know my side lengths don't look ideal, but it's a reduction of the original one. I'm not going to put the arrow in there, just the general rhombus here. It's a reduction. So let's do the same thing. Let's compare and contrast the corresponding angles. So angle W, it's a right angle there. Angle W prime also looks to be a right angle. That you should notice that that's the case for all of them. So the measure of corresponding angles is equal. And then what about side lengths? A little harder to tell because we're measuring diagonally here, but that's basically diagonally across two squares right there. From W prime to X prime, it's only diagonally across one square, which would be 1/2. It's in that same scale factor. So corresponding side lengths are also in the same scale factor of 1/2. So the angle measure stayed the same. Side lengths reduced because it's smaller than the scale factor, smaller than 1. They reduced. They're half as big as the original. So we have seen in this video that after a dilation, corresponding angles are the same. Corresponding side lengths either grow or are reduced by the exact same factor as the scale factor. In the first example, it was 3. In the second our second example, it was 1/2. Remember, scale factor bigger than 1 is going to enlarge it. Scale factor less than 1 is going to reduce it. Have a great day, guys.